Welcome. Excited to be here. Excited to see so many familiar faces and names. We are doing math together, so please keep that in mind. I'm counting on you all to get involved and to share your thinking. That's how this is going to work. There's my contact information. Please feel free to contact me. I'd love to hear from you. Here's some summary of what KCM does. Our goal is to support you, to support teachers, also to be supporting parents, and all of this is to be reaching our students. Visit our website, all sorts of resources there, including right on the top of our homepage is links to all of our virtual meetings going on over the next several weeks. Today's goal, we want to do math together. We want to pick tasks that are going to really promote reasoning and problem solving. We want to have multiple entry points so it's accessible and engages learners on multiple levels and opens up how students approach. So we're going to be very open to the way, that there will be different problem solving strategies, and that's what I want to hear today from you all. And we're looking for ways to engage with students and for us to engage with you in this new era of remote teaching, which is a challenge for all of us. We're going to look a little bit at research and the content standards we're going to address. And the first activity we're going to jump into is about matching proportional visuals. And we'll play around with that using the Jamboard. And then I've got some of my favorite proportional reasoning tasks coming from Lamont and from Hyde. So we're going to share that. I do want to touch back. It's kind of a capstone day, so I'm really pulling back to some of the research that's already been brought up. In Dee's session on Wednesday, she pulled out the formal definition of proportional reasoning. It's one of those things that is hard to define. It's very multifaceted. And kind of in sort of the nutshell, the summary definition, the layman's terms, it's really about reasoning up and down in situations where we're thinking about two quantities that are related. And so how does changing one quantity change the other? And we're looking at a very specific way of relating, and it's building on that multiplicative relationship between those quantities. As Funda pointed out, one of the best ways to engage students in mathematics is to make those connections explicit. Math itself is very abstract, but the way we make sense of the mathematics is we engage with it in the real world and physical. We engage with it through contextual situations. In our book study, many of you were seeing, the suggestion there is you start with the story problem. That's where kids make sense of why we're joining or taking apart. Same thing is true in proportional reasoning. Kids have a lot of intuition, and so if we live in that context, they can bring that intuition to it. How do we talk about the mathematics? How do we record it symbolically? How can we visualize it? So today with the match, we're going to be very explicit about how we're connecting multiple ways of describing a proportional relationship and multiple ways of visualizing that proportional relationship. Touching on the standards, we're living in some of those ratio and proportional reasoning standards that live in 6th and 7th grade. There's a lot in there. We're not doing all of it by any means. But I really want to bring attention to the cluster headings. We can look at the specific standards and absolutely need to. But honestly, the bigger picture is we're building proportional reasoning. Our goal is for students to understand ratio concepts, to be able to use that ratio reasoning to solve problems. So how do we engage students to do that? The standards pull out specific aspects and how it unfolds over multiple years. And starting specifically with, what is a ratio? What is our language for talking about ratios? And so we're going to be very explicit about that standard. But we're really continuing into the 7th grade in the bigger picture that students need to be able to analyze those proportional relationships and use them to solve problems in a context. It's that proportional reasoning. Dee also pulled us together thinking about the bigger picture of reasoning. So we're going to jump to the Jamboard here in a minute, and I'm going to ask you to make connections between these cards in these mathematical statements. So it's going to look pretty much just like this. I'm going to switch to that Jamboard because that's going to let us move the cards around and write on them and do all sorts of cool stuff with them. So, and if you're like me, you're probably juggling things around on your screen. So hopefully you can make room for all the Zoom features as well as the Jamboard here. But hopefully give me a thumbs up if you're able to see, again, the cards labeled ABC. And you're able to see the written descriptions. Awesome, Kelly. In the green and light green and orange and red box. And I just want to give you a moment and just start making connections to where one of those boxes below, one of those statements, which card do you think it matches to and why? And as you find matches, feel free to type those into the chat box. And don't feel like you need to work in any particular order. Just as you find a match, feel free to share what you're seeing. Wonderful. We're starting to get lots of lots of contributions. So you're seeing those matches. You're starting to see what other people are typing in. I think it's coming together. So let's go ahead and pick those and go ahead and verbalize what we're seeing the connections are and why. I'm going to kind of scroll back to that chat box. And I think I want to start with, let's start with the 2/5 card. And I think we've had a couple people talk about why that matches to C. So I'm going to go ahead and pull this up here. And we'll just briefly have somebody volunteer, give me an explanation of why you see those as a match. Give ourselves some working room. Mary Green, do you have mic? Would you be willing to share that? I think it's Mary. I'm Green.
It's Monique.
Oh, thank you. Sorry about that. I know Mary Green and that just popped in my head. So go ahead, Monique.
The 2/5, I see 2 gray dots out of 5 total.
Okay, so that's exactly it. Of course, my pen decides right now not to connect that. Wow, that's interesting. Okay, so there, now we got working screen. So we see those 2 gray boxes, and I was trying to be in laser pointers. So we saw those 2 gray dots out of the 5. Perfect, that's exactly what I wanted to do. Let's see, Lisa, you saw that B matches to that 3/4 card. Would you be willing to share why you saw that?
Yes, ma'am. There are 12 total, so 3 is 1/4, and there are 9 gray, so that's 3/4 of the set.
I noticed that you had to pull out there how that 9 to 12 related to that 3/4. So how did you visualize that? Or how did you know about that equivalence? Was it numerical or was it visual for you?
Actually, visual.
Tell me a little bit about that.
Well, in the center, I could see that there were the set of 3. And then to the right and left, there's a set of 3. And then above is a set of 3. So, you know I'm visual, Cindy.
I had a hunch. So I want to capture that again. You saw there, is that right?
Yes, ma'am. And then you got it. Yep.
Awesome. So really seeing those groups that made the 3 groups of gray to a total of 4 equal groups. Okay, let's go ahead. We got 2 more to match. I'm going to start calling on people. Let's see. A went to yellow. And Darren, would you be willing to share that?
Yeah, I saw that there were 4 gray dots to 2 white dots, and that ratio will simplify to 2 to 1.
And you saw the relationship. Okay, so that 4 to 2 is equal to that 2 to 1. Okay. And last one. And so you can decide with kids how much you want to dig into having rephrasing or repeating going on. Let's see, do a volunteer to tell me where this last card should go. I've lost in my chat box who might have had that.
I can go, Cindy.
Please, thank you, Funda.
So I like Lisa's visual representation. I first went with the numbers, but when we look at the screen and the visual representation, I see 3 circle sets in the gray ones, and then I just see 1 set that you circled in the white one. So that's 3 to 1.
Awesome. Okay, so this is the initial match, and there's a link on the PowerPoint that actually shows you where I found essentially this activity with a little bit of tweaking. But I wanted to take it a little bit further because there's some really amazing work going on in a lot of our elementary schools where we're using bar models. And bar models are amazing for representing proportional relationships, and especially when we don't actually have the exact quantity. We just know the proportional relationship. So I want you to think about that bar model for a moment and think about which of these cards, now we also have what the card represents as a fraction, but we also have what this card represents as a ratio. We have the words. So which of these does that go with and why?
Can you pull the other cards as well?
Sure. So I do have some other cards. So as students, you can decide if you want to give them all the cards at once.
Oh, I see. Okay. So you do 1 at a time? I'm sorry, I didn't mean to.
No, it's certainly fine. That's just kind of a decision to make. I think it's interesting. Oh, I got this one flipped upside down, which is kind of interesting too. And does it matter? So ultimately, those are the different cards that we're going to match. And so we can think about them also through that. Well, which one makes sense in which case? And so if you want to go ahead and type in the text chat, if you've got, oh, that's somebody saying they're in the right place.
You
and that was completely on accident.
Yeah, you actually opened them up and moved them in order. That's funny.
So we do have them in the right place. I actually didn't even realize that until somebody said that. So don't do that. Let's think about why. Why do we know they're in the right place? What is it that means that this bar model represents that dot imagery, or how does that bar model match to the words? I have a volunteer willing to explain that or talk about that. Need somebody to be not shy at the moment.
Can go, but I'm trying to be shy and quiet.
Go ahead, Funda.
Okay, I'll go. So I like this bar model because it makes a comparison easier than the set model for me. That's what I want to start, because I can see, for example, with the A, 2 to 1, I need to circle out the sets, 2 gray, in the representation visual, in the set model to see. But when you say the bar model, it's just 2 right away there. So I think it's easier to connect 2-to-1 ratio numerically to the bar model because it's obviously already 2-to-1. So if I'm just going with the numbers, again, if we go to the B set, if I just go to the proportional relation 3-to-4 instead of the set, I can just see 3-to-4. I see 3 grays and 3-to-1, 3 grays and 1 white. So it's 1-to-1 corresponds to the bar graphs that we have. Yeah, 3-to-1. But we did for the C, we don't have the ratio, right? To white, so 2-to-3. So we need to interpret that from the representation. So we need to see how that 2-to-3 comes. And when I look at my C, I think we count each individual dots as 1. So I see 2 gray and 3 white. Yes, thank you. Thank you for blinking. So that was for me kind of different. Nice.
So when we start seeing that correlation, so the 2 to the 3, the 2 dots, 1 dot goes in each square. One of the things I'd play around with students is, and I like the Jamboard and the dynamic aspect of it, is here it's that 1 dot per part represented in the bar model. But here I start having to juggle that. We can see the 3 groups to the 1 group, but we again can actually move those dots and place them into that bar model and really make explicit how each of those rectangles in that bar represents an equal grouping. And we have those 3 equal groupings of gray and that 1 same sized group, but of the white. Okay. And we could do similarly for the other card. There are some other ways that you could play with this, and this Jamboard will be shared with you kind of in that reset version, so you can play around with it. Funda, you talked a little bit about having not had that ratio there, so it forced you to go back to the set on this last one. It's a choice, either to not have that card there, or I could have actually have had you fill that in, and then we would have had the written ratio there. So other cards that can be used in this particular activity is having kids write in the ratio or write in the percent, write in the fraction, and play around with that. Other thoughts, questions on this particular Jamboard, as any ideas pulled out for it, any aha moments for you, or just questions for me as we do this. I'm also going to show you in a second that we have a paper printable version of a card sort that does a very similar thing. But in terms of just the math behind this or using the Jamboard, any questions or reflections on that?
This would just be like an extension, but using like Q's and error rods to have kids make up their own with like that would match those.
Yeah, I love the C rods, and they're so magnificent for any kind of proportional relationship like this. Beautiful connection. So as we take it back, in the PowerPoint notes, I did have this card for you, or this image for you, because I kind of anticipated that this conversation would go and pull out some of these ideas. So I wanted to have it in the PowerPoint as a reference of how that Jamboard might look. And also just as a reminder of what is our purpose in doing this matching activity. We want to take them from a set model where, students start in around 4th grade looking at set models similar to that, and seeing it as representing a fraction, and seeing representing 9/12, and knowing that that 9/12 is equivalent to 3/4. And that lives in our standards. It's work students should be doing around 4th and well into 5th grade. Also, students should be using in elementary things like the bar model to represent contexts that are given in a multiplicative way. This ladder is 3 times bigger than the short ladder, and kids draw something like that bar model representing that relationship, depending on your curriculum and the background, but it's certainly a tool that we encourage teachers to use and have found very effective. So what's going on in 6th grade is we're starting to link in that ratio. We're starting to go to that part-to-part language, focusing on part-to-part, and not always living in a part-to-whole language. So now we also can talk about the gray to white and capturing that 3-to-1 relationship instead of always going back to the 4 equal parts. We can focus in on more that 3-to-1 and use the proportional relationship between that. And see in that 3-to-1 situation, it might be 9-to-3, it might be 6-to-2, it might be 3-to-1, we could scale up. And when kids are comfortable recognizing that, as long as it's an equal number of pieces in each block, we've preserved that proportional relationship. So the card sort does very similar. There's a few more matches because if kids are working a little more independently or in pairs, I'm going to give them more opportunities for some of that trial and error and process of elimination and thinking about, does this set go with this set? So you've got 5 different sets going on where there's 5 different circle representations. There are 5 different fraction cards, but one of them is you're going to have to fill in your own number. There are 5 different ratio cards, but again, one of them you're going to have to fill in your own numbers. Are you making sense of this? On page 2, and I really would recommend it be a second page because I think it gets too many things going if we give the kids all the same cards at the same time. Then we have the bar model cards, and again, there's a blank card with the idea that you would make your own bar model to go for the set that is missing a card. And then as an extension activity, kids could actually make their own set of 4 cards. Color in some gray, so now what fraction of the set is gray, or what's your ratio, and how would you represent that with a bar model? So those resources are available to you, and I felt like it was really important that we give you both sort of that digital interaction, how would I foster a discussion about these ideas, but also how would we provide this to students who may not be online with us. So for the rest of the time, I just want to share some of my favorite proportional reasoning tasks. And these are coming from Lamont. They're also coming from Hyde. And they're just range of problems. They are not in a particular sequence of complexity. And even what is complex for one person, like is just kind of pops in the head for another person. It's really kind of amazing. So I would really encourage, if you're using these, really be playful about it, be open about it, say pick one and solve, find one on the sheet that you're comfortable solving, find 2 or try one a day. But really let kids not only have choice about how they're solving it, but I'd really encourage to have choice about which one they're solving. And as they solve one, they start getting more tools to solve another, and those connections grow. Having said that, I do want to actually pick a problem out. Because I want us to have a discussion as teachers about some of the different strategies students might have if they're solving the task. So I'm going to go ahead and start with the pizza problem. I'm going to give you a moment to read through that and think about what the scenario is. And think about how you would be serving your pizzas in this situation. And this is where the paper and pencil might be handy because you might need to jot down some things, because I am actually asking you to do the math and think about how you're approaching it. And I'm going to pop over here to a Jamboard so I will have a place to record your thinking. I can tell people are doing some work. In an in-person situation, this is where I'd have you go to a think, pair, share kind of format. So I'm still struggling with how to manage that in this situation. But I will suggest if you have one of the tables, so we're sharing out, we've got 18 pizzas. The server needs to know how many to put on the different tables. Just go ahead and share one of the tables if you figured it out. Like pick a table. Is it the table of 12? Is it the table of 4? Whatever. And how many pizzas you think should go on that table. Darren, I appreciate that you're adding in some of your thinking, because it's interesting on this problem. It has a surprising, to me, it's been a surprising range of starting points that people use. Okay, so I hope we've at least had enough time to at least wrap our mind kind of around the situation. You have a good visual of, I've got these number of pizzas, I'm figuring out how to serve those out. I want to dig into Darren's thinking a little bit, because Darren, I think this probably captures what you just said a moment ago. And I'll go ahead and jump into this, but you mentioned this idea of it's half the number of people, so it's half the number of pizzas, and working down to that, splitting it up. Did you continue with that thinking? Or would you kind of tell us a little bit about how you built on that thinking?
Yeah, I mean, I did divided by 2 again for the 6. And then I divided by 3 to get the 2. And then I doubled the 2 to get to 4.
That's interesting. Why did you go down to the, I guess, yeah, that makes sense to me, I guess. And so from the 2, then you could go back to the 4.
Yeah.
Okay. Somebody else thinks similarly, that you work down, kind of splitting and looking for that relationship of, if I have the number of people, then that's what happens to the pizzas. If I third the number of people, I'm going to third the number of pizzas. Anybody else have that similar thinking? No, maybe not, or maybe we're shy. Anybody have a question about that kind of thinking? Okay.
I like
That's
that.
certainly, go ahead.
I like that thinking. I didn't think that way, but I like that table and then trying to balance that relation. Mine was more numeric thinking and trying to equate everything to a constant ratio that I figured out.
Do I have a hunch? Is that a little more in line with your thinking? The ratio?
Yeah, this ratio. Yes, that's what I had. 3/4 is the table, fair distribution, all the pizzas per person. So how can I find that ratio per table? So I set up proportion for each table with 3/4 equal to something, and the denominator was number of people in the table.
And the denominator was number of people. Gotcha. So if we look at that 3/4, trying to get where I can record. So that 3/4, oops, that did not work. So the 3/4 is equal to an X, and you said the denominator would be the number of people. So like if I had a table of 12, that kind of capture the problem that you solved for each of them? Okay.
And then at the end, I made sure I have 18 pizzas though, so that I know.
So that was your test that your thinking was correct?
Yes, kind of, because you can find different proportions, different numbers. So that was my test, yes.
Gotcha, because this could have been X over 12, but it was also for the table of 6 was X over 6. And I figure out how many goes to the table of 6, or X over 2 will tell me how many go to the table of 2. Gotcha. They have a different reasoning that they used for this problem. Even if you didn't finish it, kind of had a different approach.
Well, Cindy, I'll put mine out there.
Right, Lisa?
It was similar to Funda's, but I wasn't really thinking ratio. I just figured out what fractional part each table was and determined it that way.
Oh, okay.
So I knew the table of 12 was half. So I figured out. And then the 6 would be a 4th. The 4 would be a 6th of the total, and the 2 would be a 12th. So
Okay, I want to capture that one because even that one's a little different than what I've had before. Oh, I love it. I love the range. So you're saying when you thought about the 12, you thought about that as being half of the 18.
Right.
And when you thought of the 4, you didn't go back to 12, you went back to the 24th. So that was 1/6.
So the table of 6, no, mine went from the 12 to the table of 6, which
Okay,
was
I'll do that.
1/4, which would be 1/4 of the 24 total
So the
of
6
the group. The
would be
6 people were 1/4 of the group, so I knew it was 1/4 of the pizzas.
So because your thinking was going back, 6 is 1/4 of 24.
Right, yeah.
Gotcha, gotcha.
Yeah, and so then the next one would be the table of 4, would be 1/6 of the 24. So
Because that's equal to 1/6 of 24,
right,
then it's 1/6 of 18.
correct.
Gotcha, gotcha. And see, we see this different approaching, ways to approach it, because one of the things that's so interesting about proportional relationships is there's so many directions to the connections. And Kim, you're referring to that 3/4 of a pizza per person. Funda, that 3/4 lives in Funda strategy, where she's equating to that 3/4 pizza per person. I did this with my son, and he was very focused on that. Each person gets 3/4 unit rate kind of thinking. So if it's 12 people, it's going to be 12 times that unit rate of 3/4. Or if it's 6 people, it's 6 times that 3/4 of unit rate. And then sort of tested that he used all the pizzas. Why I love this problem is because all those thinkings are correct. We can go to a unit rate, but we don't have to. We can focus in. Sometimes when you're doing proportional reasoning, you're really focused in on, well, how do the people change? Then the pizza has to change the same way. But other times you're very focused on, you saw other strategies very focused on the across relationship. If the relationship from people to pizza is always 3/4. So if I keep that 3/4, then I'm keeping that proportional relationship. And so I just want you to play around and see that range of strategies that can come out, even, whether or not you get sort of the right answer. It could be that focus in on that K being that 3/4, but it could also be more of a scale up, scale down. If I'm having and taking a third and doubling, I keep those relationships. So it depends. Like, I couldn't always identify which standard we were living in, because it wasn't always a unit rate approach. It might be, but it might not be. Some people get to the end of this problem and never have the thought each person gets 3/4 of a pizza. They only think about it in terms of the relationship being preserved as I have the number of people or a third the number of people, and others are very focused in on that unit rate. And as teachers, we need to be really open to those different strategies that students might have. So I wanted us to see, even in a room of math teachers, we see those different strategies. Some of the other problems, we don't have time to do them. Never know how long these are going to take, but there are Jamboards set up to do them. There's the mowing problem, and there's some visuals in there if you want to use that problem. There's another one. This one's a little wild because it's got 3 relationships going together. So if you want to challenge yourself with some weekend math, it's a lot of fun, because if 3 people can make 5 seismometers in 8 hours, how many do we need to make 100 meters in 24 hours? That's a lot of relationships to interconnect, and it's a lot of fun. So, and I should change the heading on that, because that's not pizza party. So, if you want to play with that math and send me your solution, I would love to see it and love to talk math with you. So feel free to let me know. I also tossed in this tile pile as a Desmos activity, nice interactive activity that does a lot with scaling up by looking at area. And then in a nutshell, the kids figure out it takes 16 tiles to cover this 4 square foot block. And then they scale it up to think about, well, what if I have a 20 square foot lawn, or what if it's 72 square feet? And it has them work both visually and with the table. So it's very intentional. It doesn't really get to the function like these did the other day, but it's very focused on the ratio table and connecting to this context of tiling the floor and seeing if it's 4 to 16, how does that relationship preserve as I think about tiling a bigger floor? And remember, what our goal, we can think about it as being able to do this thing or solve this kind of problem. Yes, But the bigger goal is to really preserve or build that proportional reasoning, that understanding of how quantities are linked and both changing in a way that's the same. And I encourage you to go back. We've got previous sessions that you can go back and check out for middle school. We've got some high school sessions going on that are awesome on Thursday afternoons. And we'll continue to have 2 o'clock sessions next week looking at intervention. And all those links and resources will continue to be available at our website. Feel free to reach out. I would love to hear if you take any of those problems and tackle them, and see your thinking and to talk out ideas. So be happy to hear from you. Let me go ahead.
We always end with giving Cindy some props and some feedback about kind of pulling and pushing on our thinking with regards to proportional reasoning. So in the chat box, or unmute yourself. We're an intimate group today. Unmute yourself and talk to Cindy a little bit about what you loved.
I did love doing math together. I just love it. It's like becoming a habit. I need to go to this 2 p.m. sessions and do some math thinking. I love it. Thank you, Cindy. It was a great session.
I appreciate you jumping in and sharing ideas. That was awesome.
Yeah, I did too, Cindy. I loved it all. And I really love the bar model that you use with the fractions and ratios. I thought that was really neat.
I'm excited. That's been a new piece for me. I certainly didn't grow up with the bar model and seeing it for proportional reasoning. I am so excited about that piece. It just makes it visual in an amazing way. Appreciate the comments.
We tested
Thanks, Kim.
on my husband. It was great fun to do that with us. It was very cool.
Yep, he's a good sport. He let me learn on him.
It was great. It was great.
So we're so glad to have you guys join us in the afternoons. 2 o'clock is our special time, but always you can find us on the Kentucky Center Mathematics website, and our videos will live there. Please think about how you're going to use these when school gets back, because you can use them in your PLC sessions. You can share them with your district administration. They make for great conversations. So we thank you. See you next week.